All right. Good morning. Good afternoon again, everyone. Thanks again for joining our Lunch and Learn session today. Today we have a session presented by one of our wonderful partners, Slalom, and our speakers today will be Merrick Koenig and Sean Hayward, and they'll be presenting today on retail site selection with Google Places API. Very exciting. As a couple things for logistics, I want to go ahead and point out some upcoming trainings that will also be available, again, presented by these same partners. You can join us again on November 17th, so that'll be next week, on a session about digital marketing insights with Google Analytics. And then again in early December, so after Thanksgiving, we'll have another session on harnessing predictive analytics for employee attrition. Also, for a couple of logistics today, we're expecting the session to be about an hour or so feel free to join. Everyone has been muted as soon as they enter this room. And so if you do find that you've come unmuted at some point during the session, I will either manually mute you or please just make sure to keep an eye on your microphones and make sure that you're not sending some background noise that might hinder us from hearing what our presenter is talking about. If you do have a question during the course of this session, please feel free to enter that into the chat. If you're on the WebEx, you'll see that option in the top right-hand corner of your screen. There's a couple buttons there, and one of them is chat. And please make sure to send that to the presenter or send that to everyone, so that way we can address that question later on in the presentation when we have a moment. This session is also being recorded. And that will also be sent out probably sometime early next week to everyone who is signed up and registered for this session. So you'll be able to replay this again if you missed something. And with that, I will go ahead and pass it on over to our presenters, Merrick and Sean.
Okay, great. Thanks a lot. And again, good morning and good afternoon to everyone, of course, depending on where you are today. So my name is Sean Hayward, and I'm one of the solution principals at Slalom, based out of our Dallas office. And I'm primarily responsible for Alteryx enablement. So I just want to spend just a minute or two before the presentation letting you know who and what Slalom is. So Slalom is a consulting company, and we essentially try to help our clients solve their business problems. And we do this over a number of different areas, specifically spanning things like business advisory, looking at customer experience, and how we can use technology and analytics to drive those things forward. We have offices in over 24 markets, and you can see those on the screen now. We have about 4,000 employees internationally at the moment. We work on a local model. What that really means is our consultants live and work in the same cities as our customers. And that means we really get to partner with our customers to help them solve their problems, and we can work on those things together through real close collaboration. Now, where it comes to Alteryx, we are an Alteryx partner, and we were awarded Channel Partner of the Year in 2016. And Systems Integration Partner of the Year in 2017. We have a number of Alteryx certified consultants, and in fact, we have more certified consultants than any other Alteryx partner. So if you're looking for some help with Alteryx, we would absolutely love to help you build some amazing solutions. So I would ask, if you want any more information on that ground, feel free to contact either myself or you can reach out to Merrick. Our contact details on the screen. Of course, you can always go to Alteryx or you can go to slalom.com. So talking of great certified consultants, Merrick Koenig is one of our most highly experienced solution architects here at Slalom with a number of years of Alteryx experience. He's been doing some amazing stuff with the geospatial capabilities within Alteryx and, linking that out to APIs and doing some pretty cool stuff. So I think you're really going to enjoy today's presentation. So with that, and Merrick has just got that his email address is wrong, so I will make sure I correct that for the next one. So let me reassign this to Merrick over here. All right, Merrick, it's all yours.
All right, with that audio issue resolved, thank you again for joining today's Lunch and Learn on the topic of retail site selection with the Google Places API. I'll be walking through a client solution that I built earlier this year for a commercial real estate client. The solution is broken down into a few different workflows with the ultimate goal of choosing a retailer for a new location. But first, I wanted to provide a little background of why this solution was built in Alteryx. My client, as I previously mentioned, was a commercial real estate broker. Their main responsibility was to help cities identify candidate retailers to occupy new or vacant retail locations. So think like a strip mall or something like that that may be anchored by a big retailer like a CVS. They would previously do this the old school way of crunching numbers in Excel and looking at a few outputs from their GIS systems. This manual process would take them over 8 hours for a single site. So as you can imagine, that's a lot of time to get not a whole lot of results. We stepped in and built them a optimized process that gives them an answer with a push of a button and a few seconds of processing. To understand the solution, let's step through a high level of what I'll be covering today and the tools that I accomplished it with. The first part of the solution was to obtain a complete list of retailers that my client cared about. They knew that the data was available in Google Maps, but didn't know how to really get it out. And they didn't want to have to pay somebody $10,000 each year for a refreshed data set. To get that data out of the Google Places API, we needed to first understand what our results look like. And we can visualize that here on the screen by going to Google Maps and searching for 7-Eleven. As you can see, I only get a subset of those results because they are so tightly packed into this high population area, while other retailers, like Best Buy, are more spread out. To ensure consistent results each time, I needed to determine the most optimal query radius for the Google Places API. Using 7-Eleven as my edge case scenario, I found that I would not need more than 20 more locations in an 8-kilometer query. I could have subdivided the USN in those 8-kilometer circles, but that would result in more than 50,000 queries for each retailer. And if you're familiar with the way this API works, I would run out of my free queries very quickly. So I'll go into more detail once we crack open Alteryx, but I wanted to provide you with a visual of first how I gridded out the US. You can see here, I used population density to mainly drive the grid size. With such high population areas, you'd expect to have more 7-Elevens and the similar retailers to that. And the low population ones would allow for a more generous query radius. So you can see here the more highly dense grid areas. These are our metropolitan statistical areas, or MSAs, and the larger grid size is everything outside of that. We then used that map to drive what we sent to the Google Places API. Then we'll get some additional retailer information from a detail API. After getting all of our retail data, we'll build a demographic profile for each location, and finally we'll run through an example of doing a site selection. But before we do that, I wanted to do a quick run through of the tools that I'll be using today. As you can imagine, most of these tools live in the Spatial tab, which is green, so all of the icons show up as green. But we also have a few that come from the Connector and Developer section, so they're both this kind of gray color. The first tool that we'll be using today is the Trade Area tool. This tool lets you generate a ring around a specific point, and we'll use that ring to summarize demographic data in the vicinity of that point. Next is the Spatial Match tool. With this, you'll be able to compare two sets of spatial data and see whether or not there's overlap within those two areas. Another tool that we'll be using is the Make a Grid tool, which is one of my favorite tools. It lets you subdivide a geospatial area into smaller areas, and we'll use that to build out that nifty gridded US image that I just showed a few moments ago. We'll also be using the Spatial Info tool. With this, we'll be able to pull out the spatial information like latitudes and longitudes from a point. With the Spatial Process tool, we can cut or add two spatial data sets. So just literally think of taking two shapes, seeing where one can take out a piece of the other. And the last spatial tool that we'll use will be the Create Points tool. This converts a latitude and longitude into a single value. Some other tools that we'll be using are the download tool, the JSON parse, and the block until done. And these tools let you download data from a URL, then parse those results in a JSON format. And the final one is it lets you stop all processing until all data has reached this point. All right, let's go into Alteryx and actually talk about what we've built. Let's start off by looking at what we did to create a grid of the US. This is the most important piece of the entire process because with a grid size too big, we'll miss some of the results, and with a grid size too small, we'll query the Google Places API too much and run up our tab. The process starts off by combining our various inputs that are all connected wirelessly. You can see here I have this inputs folder here. The inputs consist of spatial data that is representing our MSA data, our zip code data, and our population densities. So as I mentioned, all of these are connected wirelessly, so you can click on them and see where they go. And you can also have a very clean canvas to make it look nice and pretty. So the first thing I do is I do a spatial match after cleaning up and selecting my columns. I do a spatial match to remove all of the locations that are in an MSA. Specifically, I tell the tool to only return where the target intersects the universe. These will be our higher population areas. So you can see here my target is this red line here coming from these two inputs. And then my universe is my set of MSAs. And I'm only returning the results that match that data. I then summarize that population and the landmass for the spatial object and determine the population density. So literally what I'm doing is summarizing that population, the landmass, and grouping it by the CVS A code, which is another term for the MSA. Using those values, I determine a population density. So I take the population divided by the landmass, and I get a population density, so we can see what those results are. You can see we have our population numbers, we have our landmass, we have our various CBSA codes, and we have our population densities. So as you can imagine, a higher population density number means that there's more people there per kilometer, so we'll use that to determine what size of grid we want to use. Alteryx has a great built-in feature that will automatically divide a spatial object. I use that feature to create my grid of either 8 or 30-kilometer grids. So you can see here, I use that population density to drive a grid size formula. So if the population density was greater than 130, which was a number that I chose based on my runnings of the tool, I then choose a very dense grid size of 8 kilometers, otherwise a 30-kilometer grid size. So if that grid size was 8 kilometers, I then use this grid tool, which all it takes is a spatial object field, which is, in this case, my MSA and US map, and I subdivide it into 8-kilometer grids. If it doesn't match that 8-kilometer grid size filter, then I create a 30-kilometer grid for the less populated areas. And right above here, I do pretty much the same, but for all the data that doesn't match my MSA. So all the data outside of the MSA, which I know will be a lower population density, so I just make it a 40-kilometer grid. After that, I get the spatial information out of the points or the grids that I've created. So each of these grids now, I want to get the center point as an X and Y field. So that will return the latitude and longitude for each of my individual grids. And then I take all that data, add a new grid size field to it, and save my data out to a YXDB file. And that output here, again, is visualized like this. So each of these grids you can think of will have a point in the middle, and I'll use those center points as my query point for the Google Places API. Now that I have a set of 32,000 grids and lat and long coordinates, I can query Google Places and find all the retailers I care about. To make this process repeatable, I have an Excel sheet that I use as an input to track which retailers I want to query for. So let's go ahead and quickly open that up. So you can see here, there's the Excel sheet I was talking about. I have the retailers that I've queried for, which is these top 10. So I've created a listing for 7-Eleven, Lowe's, etc. And I want to do a new map for all of the Tom Thumbs in the US. So I'll close this down. And now back in Alteryx, I've already executed this, so we can step through the results and we can talk through what's going on in the background. Since this process does take about an hour to query the entire US, I designed it so that it would only query results that haven't been run for already. So to do that, I created a unique ID based off the query itself. And we can see here that value is here within our request URL. And we bring in our data from both that trade area YXDB file, which contains all of our 32,000 grids, so each grid with each individual latitude and longitude location. I join that with my retailer selection file, which we just looked at. You can see here we have our 11 results, and I've flagged only that Tom Thumb retailer as to be used. So I filter out only the ones that I care about, and then using this append tool, I add that Google name to each of the grid locations. Using that, I clean up my data a little bit to make sure that when I send it to the Google Places API that I have all the extra characters taken care of. And then I build my actual request URL string. So this is literally a URL that you can take and open in a browser. You pass in the latitude, the longitude, a keyword, which is the Google name. So in this case, it'll be Tom Thumb, along with a grid size that comes from my data, and the key, which I've obscured for this purpose because it's not relevant to what we're talking about. Those results, to make sure that this runs very quickly, I do a quick sample on to only return the first 200. If we had more time, I would have it return more, but in this case, we'll look at the first 200. I then take those results, and for each of these individual request URLs, I send it to this download tool. Each of those responses, I do a simple JSON parse on the download data that comes back from the query. I do a little bit of cleanup on the values to really focus on the fields that I care about and to filter out fields that have no results in them. The first section up here where I've highlighted in no results, I want to make sure that I don't rerun the query for grids that don't have any results. So I save that out into a separate output. But in our main section where we continue, I get all my results for the fields that I care about. So I care about the geometry location, the ID, the vicinity, the place ID, and a couple of other fields. So all those fields are, as you can see, in the need of being transposed. So they appear in individual rows. I do a crosstab to create the actual individual columns. And then since we do have the possibility of some overlap occurring, since some of these grids are pretty tightly packed and our Google Maps query could be larger than the grid itself, I want to only return the unique results. So that returns less. So we went from, in this case, we had 24 inputs and our output is also 24. So we didn't clean up any there. We select the columns that we specifically care about, and then using this block until done, I append my data to my retailer's YXDB file. So again, I wanted to point out this block until done, which is a great tool to use if you're trying to append data to a file that doesn't normally support appending, like this YXDB file. So I'm doing that with a union where I'm bringing in the data from that retailer's YXDB file and unioning it to my current output and saving it to that YXDB file. Now that I have a set of results, I need to get some additional data that wasn't returned initially from that API. Specifically, I need the full address, the phone number, and website for each retailer. Using a very similar process as before, very similar structure, I will kick that off and run through here. So we have our two input files. We have our original retailer's file, our additional info file that we want to make sure that we're not querying again. Choosing our first few hundred records to go through. So you can see here we're taking some data that I deleted to make this go through. So you can see here we're going to query a Tom Thumb, a couple Walmarts, send that along to our API, which is this. In this place, it's our details API versus the Google Places API. Same thing with the JSON, clean it up a little bit, do another crosstab, and format our data to get exactly what we want. So we want our address, we want our phone number, we want the name, the website, and we want all of that address information split out. And again, doing the same thing as we did before, we do a union, a block until done, and then we append our file. Now, with a data set of all my relevant retailer information, I need to build a demographic profile for each location. This profile will drive the retail site selection process and will determine if a location is a suitable match for a new tenant. To do this, I need to consume a new input and a new input that we haven't talked about, which is data at a block group level. If you're not familiar with this term, think of something that's smaller than a zip code. Each of these blocks has a ton of different demographic data that my client has purchased, but we really only care about three specific metrics: the total population, the median household income, and the number of daytime employees. The criteria for building a demographic profile is anything within a 3-mile radius of a specific point. So to do that, we'll take all of our data that we started off with. So we have our retailer's additional data, we have our retailer's file, bring it all together along with our selection file, and exclude all of the data that we've already added to our output file. So we can see here our output file is this location and demographics file. So anything that's coming out of the left, we're going to process. Let's go ahead and hit play on this. So we take all that data for all those individual points, we create a spatial point, and then we create a 3-mile ring around each of those. Using that 3-mile ring, we do another spatial match with our demographic data, which is coming out of this CAD file. And then we build a grid around that data. So to help you visualize what's going on here, once this is finished running, I will show you what this is doing for each individual point. So while this is running, so we've taken each of these individual grids, which I'll show here on this map. So we can see that we're building these demographic profiles for all these different points that came from our input file. And each of these locations right now is literally just a point with a circle around it. Now, to get a good result and to build that demographic profile, we need to understand what that trade block data looks like within it. So if I zoom back in to each of these individual points, we can see that we've now taken that grid size and subdivided each of our trade blocks, and we can see that this 3-mile circle encompasses more of the trade block group. And to get an accurate result, we want to see exactly how much of that trade block actually exists within this circle. So to do that, we need to first count the number of blocks that exist within the circle and the ones that don't exist outside of it. So to do that, I quickly summarize and do a count of the total of grid names within that area. And then I see which ones exist outside of it using this spatial process tool. So I'm literally taking the grid as my first spatial input and then the spatial object of the trade area, so the trade blocks, and then I'm creating an intersection, so only getting the ones that exist within that circle. So here we have our larger number of total count, and here we'll have our smaller number. We bring that all together and create a coverage percentage formula. So we take our intersected count divided by the total count, and we can see here that a lot of them have a high coverage while some of them have a smaller amount of coverage. So we'll take that number and pass it along into our demographics data. So with that, so each of these files has our demographics data. So what we want is we want to actually then take and summarize those individual trade block groups, which are here identified as a ULI. So I want to first calculate the median household income, do the average, and then summarize the number of employees and the population estimates. I take those results and return only the unique results. So we have those 26 results that we care about, and I save that off into my location and demographics Excel file. So let's open that up so you can see what those results look like. So we can see here we have all of the locations that we started off with and even some more. So this is the individual retail locations along with each specific demographic estimate. So we can see that we have a location in New York. That's a 7-Eleven with a specific latitude and longitude, a website, a zip code. We have their full address, and we also have their demographics information. We're almost to the end of our solution, and all the previous steps that I've just shown you only really need to be run a single time to build your demographic data set. Once you have that, you can run the retail site selection tool very quickly. To determine what retail location we want to analyze, I built a macro here that takes the starting point location and analyzes it for demographics and compares it to our input data set. So I won't go specifically into this macro, but just to show you how it works, we can open it up here, and it's starting off with a location here next to the Slalom office in Dallas. And what I want to do is I want to clear that location, and I want to put a new location, and let's say up one of these highways up here. That looks like a good location. So we do that, choose our location, hit play to process that location. And now, as you can see here, this entire process ran very quickly. It took about 5 seconds, which is super fast compared to what my client was doing before, and they had to do all this by hand with all their GIS tools and Excel. And like I mentioned before, it took them about 8 hours to do this for one single location. So you can only imagine that ROI that we've provided to them. So what we're doing here within this tool, we take all of our location and demographics data, which we can see here is about 23,000 individual locations. We want to select the specific columns that are relevant for this case, create a population tiering, which is relevant for our client. So they want to make sure that we compare only similar population tiers to similar retail site selections. We then summarize that data, again, to only return the high-level retailer. So instead of having each individual retailer, we have one line for each retailer. So we can see here that 7-Eleven is considered a Tier 1 with a count of 1,338 with their various demographics information. And we can see here we've done that for each of the tiers as well. So we can see here that 7-Eleven and Tom Thumb and all these other retailers show up as Tier 1 all the way through Tier 5. We combine all that data together and only return data that matches our current target tier of this site selection that we chose here within this macro. We do some calculations to determine if it is a good match or not. So we do a few of those. And then we take that output and save it out to our tiered and scored locations file. So let's open that up and I'll step you through those results. So you can see here within this file, we have our retail selection and how they've all scored based on our distance and by normal category. So you can see that the 7-Elevens that we were looking at, they have a pretty high score here of 0.85, and that they're pretty close to our location. So what we're seeing here is that there's probably a good use case for maybe building a 7-Eleven in that specific location. And then we also do that by overall score. And that's it. In a few steps, we were able to build a tool to help with retail site selection. The solution wouldn't be possible without the great tools that Alteryx has provided for us. I wanted to specifically call out the spatial match tool and the grid tool. I hope you all learned something today, and I wish you luck in building great workflows in the future. And I'll pass it back to Sean, and maybe we'll take some questions.
Great. Thank you so much, Merrick. I just got a message from Sean that he currently doesn't have audio, but a couple of the questions that did come in from users while you were presenting, which was wonderful. One of that is there any possibility that you'll be able to share the workflows that you've demonstrated today?
I could definitely share a few of them. Since some of them are client proprietary, we can definitely have an offline conversation with whoever's interested to maybe share a cleaned up version of a workflow or two.
Great. Another question that just came in is, do you know which spatial data package that you were using?
That's a great question, and we actually weren't using any specific spatial packages of Alteryx. We were really just using the base level of Alteryx. That was one of the requirements for the client. They didn't want to purchase that additional spatial and data package with Alteryx.
Perfect. I'm just monitoring the chat session. If any other participants have questions they want to submit, please feel free to do that while we're taking Q&A. Merrick, while we're taking some questions, would you just mind sharing a little bit of your experience about working with the API and that process?
Yes, definitely. So the API was definitely something different and new that I got to interact with on this solution. There was a little bit of a learning curve, as with anything new. There were definitely some challenges in getting Alteryx to return all the results that I was expecting to get, and there was just a couple quick and easy configuration options that I can even just show with the group.
That would be great.
Yeah, let me go back and share my screen. All right. So my experience with the Google Places API was overall very positive, but the only quirk of the tool was to make sure that, trying to see where this option was, just to make sure that the data was encoded in the right way, because if it wasn't, then you would happen not to get all of the expected results back. So it's definitely one thing to keep in mind when using this API, but it's very easy to start off with. Anybody can sign up for a API key, and you just have to monitor your usage with it and make sure you don't cross that free threshold, which is, I think, around 150,000 queries a day.
Fantastic. And then some other questions that have come in is asking if the base package, which I'm assuming is a spatial package that we're talking about, allows for geocoding data like you showed, which we can talk a little bit about. And then another question is your authors, your contact information, which will you be sharing your presentation with us, your initial couple slides, so that way users can get in touch with you with direct questions?
I'll answer the second question first, and yes, we'll definitely be sharing our presentation on Alteryx, so we'll work with you to make that happen. I definitely want to share our contact information with everybody here on the line and everybody that watches this at a later date. The first question, dealing with spatial data and doing geocoding. We actually didn't do any specific geocoding on this example. All of our results that came out of that Google Places API were fed in by that initial grid location, which had a latitude and longitude, which we really did a create point on, so you don't need the spatial package for that. And then coming out of that Google Places API here near the end, each of these individual locations returned a latitude and longitude for us already. So Google Places, once you query it, will give you that information, so you don't have to go and do another set of geocoding, which would not be out of the box in Alteryx. At the base level, you would need the spatial package to do that.
Wonderful. Well, I think the stream of questions has slowed a little bit. So just to wrap up, again, very big thank you to both of our presenters. This is very interesting. I hope users, learners, you learned a lot too. Merrick, is there any final words you wanted to share as a wrap up before I end the recording here and let everyone go enjoy the rest of their lunch?
Yeah, I just want to say thank you all for joining us. And yeah, there's a lot of cool things you can do with Alteryx in the geospatial world and beyond. So definitely have fun exploring the different lunch and learns that we have coming up and the other ones that have been posted. There's a ton to learn, and it really is a fantastic tool.
Great. Thank you so much. We're learning, or we're looking forward to your next upcoming sessions, which again, everyone, if you're interested in joining those, please go onto the community and register for those upcoming sessions here next week, on December 1st. We'll be reaching out to everyone who registered with information with the presentation and the workflows, everything that we covered today, and also the link to the recording. So look out for that in your email early next week. Thank you again, everyone. Thank you to our presenters. Talk to you again soon.